Welcome, everybody. Thanks for coming. In today's talk, we're going to walk through how to build and evaluate data agents. I'm Josh. I'm a developer advocate at Snowflake for AI and open source. And if you want to connect with me on LinkedIn, you can scan that QR code over there on the left. And you can also find me at the Snowflake booth all day today and tomorrow. I'll give everyone a second. I think we're done scanning. Awesome. So as we get started, I first want to put you guys to work and ask you what you thought an AI agent was. So I'll take audience participation, if anybody's feeling brave. Peer programmer? OK, I like it. Anybody else? Yeah? OK. Awesome. I like it. I heard one over here. Assistant. Cool. Good answers. So the definition I wrote down is that an agent was an AI system that can perform tasks for us. So given that, oh, you saw a sneak peek, what do you think a data agent is? I'll take audience participation again.
Agent that can connect to your data and
Yeah.
read your data.
Awesome. Yeah, an agent that can connect to our data, read our data, and complete tasks with our data. Cool. So what kind of data might be useful for an agent like this? Any guesses? What data about the topic we're looking for? Cool. Awesome. Where might the data be from? Logs. Cool. Any other guesses? Databases. I like it. Yeah. What is that over there? Files. Cool. Awesome. Yeah, so I think you guys got them all. The internet, documents, databases, all good. So let's take a quick example. So say we have a research assistant agent. We want to give it access to the internet, some documents, and maybe it can query some databases too. And it can ask questions about things like the holding values of different managers, and maybe we want to ask it to create a bar chart. And maybe we want to be even more specific and tell it to use a particular unit or something like that. So how are we going to build it? So this is kind of an architecture of what we're going to build today in the demo. So as we start out, the first thing we're going to do is we're going to select what tools do we need to complete this task. And then from there, we're going to either choose a Cortex agent node or a web search node. If we go down the Cortex agent node path, we're going to actually have a subgraph available where we'll choose between structured data and unstructured data. And all that is going to happen via an API call out to Cortex agent. And then from there, whether we're taking the web search route or the Cortex agent route, we're going to take our research results, pass them into a chart generator. We're going to write some code in a Python REPL and get our chart out. We're going to use an LLM to look at the chart, figure out what it says, do some summarization, do some reflection. If it's done, we'll say, hey, we're done, and pass that result out. And then if not, we'll try and go back to the tool selection, maybe do some more research and find the information we need to answer the question. And how we're going to build it, we're going to start with the Snowflake AI stack. And in particular, we'll use some LLMs. We'll use Cortex Analyst for accessing and querying our structured data. We'll use Cortex Search to do search over documents. And then we'll use observability over the top to evaluate and track our experiments. And then we'll also use LangGraph as an orchestrator on top of all of that, so we can pull in our web search and our charting capabilities. Cool. So what's hard about building data agents? One challenge that you often run into is choosing the right tool at the right time. So especially when a lot of the tools and data sources are pretty similar, how do we make sure we're choosing the right one that we need? The second challenge you often run into is data access. So when we're building an agent, how do we make sure we can anticipate the needs of the people that ask the agent questions and always have all of the data the agent needs to answer those? And then the last is we want to make sure we're not making a bunch of extra unnecessary API calls or LLM calls, and we can really efficiently complete the task. And observability can be pretty helpful with these things. So the first way is that for tool selection, we can verify it by looking at the trace, and then also our evals can give us pretty good hints on when the tool selection might have gone wrong. We can also see issues with the data access. This will often also show up in the eval results, either through maybe a low search relevance score, or we'll see hallucination down the line. And then for efficiency, we can also often identify inefficient execution flows by looking at the traces. And there's some like emerging ways to think about evaluating these. But I'd say as an industry, we're still kind of in progress on that piece. Cool. So let's get into the demo. Cool. So the first thing I want to do is just set an app name that's going to track this project, and then some keys, import some libraries. And then the first real thing I want to do is set my TruLens Snowflake connection. So this is where I'm going to do all of the logging for the evals and traces in Snowflake. And then I need to MFA. Cool. Then this agent is going to be a stateful agent, so I'm going to track the messages along with any tools I select or the path of any charts I generate. Then I can go and start building my graph. So as I said, the first tool we're going to use in this first version is the search tool. So in this first version of the app, we're going to actually only have the web search. So I'll have the search tool, and then I'll add this kind of lonely tool registry with just one tool. And then I'm going to create my tool selection vector store here. So we're going to choose the tool just by the embeddings of the description and name. I'm going to create my select tool method right here. So I'm going to do my similarity search. I'm going to pick the best one, and then if it's not relevant enough, then I'll kind of kick out and say I don't have the right tool I need to accomplish the task. The next thing I want to do is my research node. So this research node is going to create a React agent. It's going to bind with the tool that I selected. So in this case, the web search tool, if that's relevant enough to the user's query. And then I'll take the results of that research and go to the chart generator. And I'll also point out the instrumentation I'm doing here. So in particular, the thing I want to point out is that I can write like arbitrary code here to map to particular span attributes, so I can expose those and inspect those later on. So you see I'm mapping the research node input content, selected tool names, and some tool messages. I'm kind of inspecting the trace and then pulling those out so I can look at them later. Once I've done my research, I'm going to create my Python REPL tool. I'm going to save an image in this folder. And then the last thing I'll set up here is the chart summary, where I'm going to kind of look at that file path and then describe it in some detail with an LLM and do some reflection. So decide, did this chart summary actually answer the user's question or not? And then I'll put all my workflow together. I'll add my nodes and then string them all up into my graph. And then I'm going to create a wrapper class here that's just going to invoke my agent graph. And now I can register the first version of my agent. So here I'm setting the true agent I just created. I'm setting an app name, an app version. I'm connecting to Snowflake for logging. And then I'm setting the main method here to be this invoke agent graph. And then next I want to set the run create the run. So this is, you can think about it as like the data set we're going to use for testing our app. So I'm just like setting some metadata here about what this run is. And I'm going to ask it 3 questions in my data set. So the first is I wanted to ask it to help me pack coming from Atlanta all the way to London. I wanted to know, like, what does the summer temperature look like? Then I'm asking it some more targeted finance questions about the inflation rate and then some holdings in these SEC filings. And then I can start my run. So this is going to invoke my agent in batch with all of the queries in my data set. And this will take a minute or 2. And then while this runs, we can set up resources for the next version. Cool. Okay, so once this runs, we're going to have the 3 records that we just talked about. So we have our question about the weather, then our finance questions here. And you see for the weather question and one of these finance questions, we actually generated a chart. You see we have the path that it's saved at. We have a description of what the chart looked like. And we're pretty happy with this. This is kind of what we're looking for. And we can examine the execution trace. So I think this is actually like a better way to understand how the agent is actually working, is looking at the execution flow. So the first thing we did, remember back in the code, was select tools. So we can see here, we selected the web search tool. And then we passed that tool and bound it to our React agent in the research agent node. And we see these tool messages. So we see some messages about the weather in Atlanta. We see some messages about the summers in London. So this is probably pretty useful for creating that chart. Then it went to the chart node, and in particular, it executed this Python code for creating a plot. And then it went to the chart summary and chart reflection and decided that this looked pretty good. Awesome. So now let's look at one that didn't do so well. So you saw the red evaluation scores for this one, and you see this execution flow is a lot longer. So the agent kind of went in some loops. When it created this chart summary, we see it didn't generate a valid chart, and then it went back to the research agent node again, and it did that a few different times. So we have a pretty complicated execution flow here. We have some pretty low eval scores because these context chunks weren't relevant to the user's query. We have a low answer relevant score because it failed, obviously. So this gives us the clue we need, that we need to give our agent access to more data and better tools so it can answer our questions. Cool. So how do we set up those tools and give it access to that data? So as I mentioned in this slide, right here, we're going to use Cortex Analyst and Cortex Search through Cortex Agent to get access to the structured data and unstructured data. So we're going to do that. We're going to first download our data. So here, this is a nice public data set in the Snowflake marketplace for SEC filings. So I can navigate to that right here. And then I'm going to open that data set. And if I hadn't installed it already, there would be like an install button right there that would just copy it into my account. And then I'm going to go over to the Snowflake AI Studio. And I'm going to create a Cortex Analyst. So there's like a code way to do this too, but it's kind of fun to demo the UI version. So I'm going to create a new semantic model. I'm going to store this semantic model to describe this data in this agents database. Let's call it SEC, and then select some tables. So we want to select the tables that we just installed into our account. And let's select, we want to select the filing attributes and the filing index. And then let's just select all the columns from these data sets and then create our semantic model. And then the only thing we need to do from here, so you see we've already loaded in what are all the different columns in these data sets, and it's even done some sorting on which of these are facts, which of these are dimensions. The only thing we need to do is add a join between these two tables so we can understand the relationship. So we'll do that here. So we're going to join by the ADSH key, which is just like a attribute of the SEC filings. We're going to create a join here. And then we'll add it. And then if I do this right, then I'll be able to explain the data set. And this is kind of giving you a preview of what we'll do in a second. So I can have a description of the data set, but then I'll be able to ask some questions as well. So what is the total market of holdings reported by investment managers in 2023? Cortex Analyst is first interpreting the question, and then it's going to write some SQL to get the answer, and then it's going to execute that SQL for us. So you see here it's generating the interpretation. What's the total market value? It wrote some SQL, and then it executed that SQL. Cool. So the second way we need to access data is our unstructured documents. So that we're going to do with Cortex Search. So we're going to go back to the studio and click on Cortex Search, and then choose Create. We're going to choose a database and a schema. We'll create a name for our search service. We'll choose the column of the data we want to access. So I've already loaded and chunked some like Federal Reserve minutes documents all the way into my Snowflake account. So I'll select those tables there. I'll select the search column. And then I can configure my target lag, and then I can just create, and now I'm good to go. Cool. So now that I've set up the resources, I can go back into Cursor and get going with Cortex Agent. So the only thing different about the code we ran a second ago and what we're going to run now is we've added this Cortex Agent tool. So this Cortex Agent tool is going to call our REST API here, and it's going to do it with this payload. So we're selecting our Cortex Analyst, our Cortex Search. We're pointing it to the semantic model file and Cortex Search service that we just created. And then we're going to post to that request. And then once we get the response back, we're going to just parse it and get some text, SQL, and citations. And if we do get SQL, then we're going to execute that SQL and get the results. And then the other difference is that we're going to add that tool to our registry. So before it was a lonely registry, and now we have two tools. So let's run this cell. And then this one's going to be exactly the same. So we're going to create our run. And then we will start our run and then compute our metrics once it gets done running in batch. So now let's go back to the AI Observability page. and we can explore our 2 different versions of the app. So here you see on the top, this is our second version of the app when we've added the new tools with access to new data sources. So now we have our web search, but also document and SQL access. We see a better answer relevance score and a little bit better of a context relevance score. So maybe we can dive a little bit deeper and figure out why that isn't even higher. We see the 3 results from our queries here. So we asked a question about the weather. That went pretty well again. So we have a nice execution flow and a good answer relevance score. Maybe we want to dig in and see why the context relevance is only a 0.33. And what we see here is that the LM judge wasn't very happy because each of the individual context chunks didn't have descriptions about both Atlanta and London. So some of them had Atlanta and the other ones had London. But like I think that's pretty okay. So even though the top line relevant eval score was not that good, by diving in and seeing the details, I'm actually okay with this. And then importantly, we can look at the question that we got wrong before. So the first agent got this question wrong when we asked about the SEC filings, and now we have a much cleaner execution flow. So we are selecting our tools, and this time, instead of web search, our selected tool name here is Cortex Agent. And in the Cortex Agent, we have these tool messages. So here you see the interpretation of the question, the SQL it ran, and the results of that SQL. So this is what powered our chart creation. We'll go to the chart node and to the Python REPL. We can see the exact code that was generated to create our chart. And then we'll see the chart summary and reflection right here. And to make this comparison even stronger, we can actually compare these records directly. So if we select the 2 application versions, then we can choose compare. And then we can see for this data set, side by side, the results of the 2 different runs. So over here on the left is the second version where we added Cortex Agent, and the first had web search only. And if we click on this SEC filings question, we see on the left here the one that went pretty well. We have a much cleaner execution flow that you can see here, along with a much better context relevance score and answer relevance score. So this is kind of a really great way to compare what changed when we added the new resources to our agent. Awesome. So I think that gives me a great chance for questions here. Yeah, in the front.
I just wanted to know,
Yeah.
are you, when you say select tools, is that in one agent? Or are you effectively got different agents, one which is going to do the web search, one which is going to do the Cortex search and so on?
I'm selecting the tool, and then the agent is binding to only the tool I selected.
Okay, so it's all within one agent doing the work.
Yeah, right now. I think it would be maybe even cleaner if there was separate research agents, one for web search and the other one for the Cortex agent. But really good question. Yeah, I think there was a question over here. Yeah.
It might be a very similar question, but the Cortex agent, is it doing both of those things, or is it figuring out which one it's supposed to do?
It's going to figure out which one it's supposed to do, and then potentially do both, and then take the results.
If the first one is relevant enough.
I think it can even do some decomposition. So if part of the question was answerable from documents and part of it was from database, then it could do both and then synthesize it.
Thank you.
Mm-hmm. Yeah.
So I was just basically if you're doing multiple agents, how do you sort of get a balance between idempotency and the predictability of the response? Could they change?
Sorry, you said create a balance between the.
The redundancy of the operation, like if you do the same operation again, it will give the same response.
Mhm.
Or does it change between different like ones of the same agent?
Yeah, that's a really good question, and like definitely a challenge for building agents. I think that's like something I ran into often, like with the chart node in particular, but often like fails the first time, and then like try and create the same chart, and it would like be not so good again. So like one check I added in the chart generation was like adding an idempotency check there, so I'm not generating the same chart a bunch of different times. But yeah, that's definitely like a good thing to watch for, and like something you could probably see in the execution flow too. Cool. Any other questions from here? Awesome. So I think this is maybe a bit shorter talk than we had time for, but I've got a QR code if you want to check out the code yourself. So you can run the same example that we went through. Yep, yeah, I have a question in the back. Yeah, that's a good question. So Cortex Search. So there was like two tools under the hood of Cortex Agent. So the Cortex Search is only charged for the like maintaining the index. So you're not charged like per query. And then Cortex Analyst is charged like a set amount per query when you call it to generate the SQL. And I don't think there's any charge for kind of the orchestration layer on top. But we can like definitely follow up later if you want to know more. Cool. And then, oh yeah.
Sorry.
Yeah, no, you're good.
So could you use it potentially for pointing at like a log resource, Cabana or like a log stash or something like that?
Sorry, what do you mean?
Sorry, so if you wanted to use it to analyze production logs,
Mhm.
and that use the agent, is it something that it's used for Snowflake, Cortex, as a data source, basically logs?
Yeah, I think that's like not a super common use case as far as using Cortex Agent on top of the logs. I think there might be some cases where you could do the like similarity search to find logs with Cortex Search. But the other thing you could use the like eval and tracing for is that like TruLens and Snowflake AI Observability is like OTel compatible. So if you have OTel logs from your other source, then you can ingest them and view them that way. And that's like a nice transition to TruLens. So TruLens is an open source project, and it was the SDK I used in a lot in the code here for the eval and tracing. So even though we visualized it in TruLens or in Snowflake, I mean, we could actually connect to any SQL Alchemy compatible database and store it there and then view it in Streamlit if we wanted to. So if you're feeling generous and want to give TruLens a star, that would be pretty cool. Otherwise, I can take more questions for anyone that didn't raise their hand. But thank you guys so much.